Hello, my name is Stephen Gottlieb, and I made up the integrated algebra video. At this point, I would just love for you to sit back and view a sample demonstration which I made up. That way you get to see a little bit of my teaching style. We're going to subtract two radicals, and we're going to simplify it. Suppose you were asked to simplify the square root of 72 minus 3 square root of 2's. What you need to do is break up the square root of 72. You need to find the largest number that you know the square root of that goes into 72. And you know the square root of these numbers. You know the square root of 2 squared, which is 4. You know the square root of 4. You know the square root of 3 squared, which is 9. You know the square root of 9. 4 squared, 16. You know the square root of 16. 5 squared, 25. 6 squared, 36. 7 squared is 49. 8 squared is 64. And 9 squared is more than 72. So you know the square roots of the numbers that I kind of circled. And we want to know the largest number on this list that goes into 72. You have to be good at this. 64, is that it? Well, 64 times 1 is 64. 64 times 2 is going to be over 100. 49, that's really close to 50. And we know 50 times 2 is 100. Well, 49 times 2 is going to be very close to 100. It's going to be 98. That's more than 72. And of course, I wouldn't do 49 times 3. Now, 36 times 1 is 36. 36 times 2 is 72. That's the winner. I'm going to rewrite the square root of 72 as the square root of 36 times 2. After all, 36 times 2 is 72. Minus 3 square root of 2. You can't break down square root of 2 because there's no number on this list that goes into 2. Now we have this property when we have a square root of a product. As long as both of these numbers are not negative, you can take the square root separately. 36 is not negative and 2 is not negative. Only when they're both negative can't you separate it. Now, here's where the magic comes. Square root of 36 is 6 square root of 2 minus 3 square root of 2. Now, a lot of students get real nervous when they reach something like this. But these same students know, for example, that 6x minus 3x is 3x. Well, now, this statement down here is called an identity statement. That is, it's always true. No matter what x is, yeah, 6 times a number, and you take away 3 times that same number, you'll be left with 3 times the number. I'm just telling you what x is. I mean, the 6 is the same, the minus is the same, the 3 is the same, and the x's are now square root of 2. So we should get the same answer. 3 instead of x square root of 2. We are subtracting square roots of 2's. If I told you I had 6 $5 bills and somebody took, or I spent, somebody took away 3 $5 bills, you'll all agree that I have 3 $5 bills left. Well, maybe you think for this problem, that's how you write a $5 bill. Or maybe there's a new bill. It's called the square root of 2 bill. If you have 6 of these numbers, you take away 3 of the same numbers, you end up with 3 of those numbers. This completes the sample video for my integrated algebra video. I'm going to thank you for viewing it to the very end, and I definitely want to wish you great success in your integrated algebra Regents course. Thank you for watching my video. Have a good day.